welcome to the video lecture series of Theory of Computation. Today we are going to learn about the designing a Turing machine which accept the language a raised to n, b raised to n where n is greater than equal to 1. I am your instructor Poonam Patel. Let's start to understand this concept. So, in this lecture, we are going to discuss about the designing of Turing machine which accept the language a raised to n, b raised to n where n is greater than equal to 1. So first of all, we need to understand this language. Our task is to design a Turing machine which accept the language a raised to n, b raised to n. It means that the power of a and b are same. Okay. So here we have to design a Turing machine which accept the language. We can say that which accept the string which contain the same number of a's and b's. So equal number of a. So we can say that the number of a is equivalent to a number of b, and first a should appear and all b should appear after a. Okay, so in this type of string we need to accept it. First of all, whenever you are designing a Turing machine, you need to understand about the valid string. So here I have given some valid string which belongs to this language. So here you can see over here, if I take the power of n is equal to a, so the string is generated ab. So here the number of a is 1, so number of b should be 1 and b should be appear after all a's. Okay. Now if I take power of n is equal to 2, then the string is generated like a square b square, so a b b. If I take n power is equal to 3, so my string is triple a triple b. So this is the valid string which belongs to this language. Now understand how we can design the state transition diagram. So first of all, before designing the state transition diagram, we need to understand the logic that we are going to use to designing the state transition diagram. So here I have taken the one input string which is belong to this language. So here I have taken n power is 2. So my valid string is double A double B. Now you can see that I have used the symbol delta, and this delta denoted, if left hand side if you see, my head is pointed to the left hand side delta which is called as a left end of the strings, and if you see the right hand at the end of the string delta which is represented the right end of the string. Okay, so delta is denoted end of the strings, the left end, the right end. Now we understand our logic which we are going to use to develop the state transition diagram for this language. So what logic we are going to use over here? So here you can see that to accept this kind of languages where the number of a should be exactly same to the number of b's. Okay, so here the logic we have used. So here you can see in a step number 1. Step number 1 said that replace small a by a capital A. So here I have moved the now. Next is step number 2. After replacing a first A, I am going to find out my first B, because here we need to compare the counting of number of A and number of B's, between the number of A and number of B's. So first I am going to count the first A. Step number 2 said after counting a first A, I move to the step number 2. Now my step number 2 is used, move the right side, because after A, B should be appear. So where B is situated, the right side of A. So second number step said that move to the right side and finding to the first B. If it is not any B exist, we can simply reject that string. This is my step number 2. Now if I found the B, first B, when I move to the right side, when I found a first B, this B is replaced by capital B. So this is my first count, first A, first B. Now my step number 4 said that after counting a first B, again repeat the same counting. It means that move to the left, move to the right side, and move to, we can say that move to the left, to the leftmost A. Okay, so leftmost A, it means that after a first counting we have started the second counting. Now we are going to start count a second A. So leftmost A, we can say that we have to move our tap head to the left side, to the leftmost small a. Now same thing, so step number 5 said that now when you are started the second counting, the same thing is repeated. Step number 1, step number 2, step number 3, step number 4. So this thing is repeated until no more a is found. Now my step number 6. Step number 6 is said that make sure that no more bees is remaining. By doing this, if no more is, so it means there no more bees should be there. Okay. So in this way we can use this logic to accept this Turing machine. So here let us understand this logic by using the tap symbol, by using this input string. So here you can see my head is right now at delta. So we have to shift this delta at the right direction and which point to the first symbol of the my input string. So here you can see that the first. Okay. Now our logic is started. So step number 1 said that replace small a by a capital A and then move the tap head to the right direction. So here I have replaced small a by capital A. Now move my head to the right side and find the first B. So here my head is, you can see that, moving. Now they said that when you are going to move, if there is no, step number 2 said if there is no B, we can say that this is the invalid string. Now we can see that whether B is found or not. So here you can say that right now my head is small a. Now again move to the right direction. So here I am going to right direction. Now step number 3. Step number 3, if small b is found, what we are going to do? We are going to replace this small b by capital B. So here I have found my first b and which is replaced by a capital B. Now I want to repeat the same process. So my head is moving to the leftmost symbol of A. So here you can see that small a, skip. So this letter is replaced by the same symbol, small a. Move my head is left side. Again capital A I have reached. It means that I have reached where I started my counting. Now I have started. Now I am going to start my counting after this symbol. Follow the after this counted symbol. So here I moved my head to the right side. So here, so this indicates now I have started my counting at this symbol. Okay, so it means that now we can start our second counting. So when you are started second counting, it means that you have to repeat the step number 1, step number 2, step number 3. So my step number 5 said that repeat the above steps until no more is found. So here you can see that if there is A, we need to repeat the steps. So here in this my string, there is A, so we need to repeat the step. So again small a is replaced by capital A. Second letter is counted, second letter A is counted. Now going towards second counting of B. Now I am going to find the B, small b. So moving my head to the right direction. So capital B, skip it. Now I found second B. So second B is replaced by capital B. Now move to the leftmost A. Move left to the leftmost A. If you see there is no any small a remaining. So we need to check whether there is any small b remaining, because here we have identified there is no small a remaining. So we need to make sure that there is no small b should remain. So we move my head to the right side. So here B, capital B, skip it, capital B, just skip it. Now we have reached the delta. So there is no small b in my, so there is a no small b. So we have reached at the delta. So we can say that this logic is used, we can in this way this logic is used to accept this string. Now let us understand this concept by using another example. So here I have taken the nth power is 3, so triple A triple B. Same procedure I have followed. Small a replaced by capital A, so first A is counted. How we can know? Because we have used a different symbol, and this different symbol is indicating this A is counted. Now I am going to move to the first B. First B if I found, replaced by capital B. Now move on the second A. Second A replaced by capital A. Again second B is replaced by capital B. Move to the left, find out the third A. Third A replaced by capital A. Move to the right side, find out the third B replaced by a capital B. Now we can see that my all letters are converted into a capital letters, all A, all B's. So we can say that this string is accepted. Now let us understand this logic by using the state transition diagram. You can see. So for understanding the state transition diagram of Turing machine, we have taken the we have taken the input string which my tab contains. So here I have taken the input string delta double A double B. So my input is double A double B. Okay, right now my pointer is pointing to the first and left end of the strings. So we can say that our starting of the string. Okay, so before the starting of the string, delta, it means that empty cell. So delta is denoted to the empty cell. Always remember. So those cells are empty, we can denote it by the delta. So here my pointer is left end of the string, which is denoted by a delta, and my pointer is always pointed to that delta. Okay, now I am going to start the tracing, so you can understand this transition diagram. And in this transition diagram we have used the logic which we have already discussed in a previous slide. So the same logic we have used over here. Now understand this logic, how we can use this logic and develop this state, how this state transition works. So here you can see that initially we are at Q0 state. So what we are going to do? We are just moving the first character of the input string. So what we are going to do? We are just transfer the head to the right hand side of the symbol of this right hand side. So what we are going to do? Delta is replaced by the delta and move my head to the right side. So here you can see that my head is moving to the right side, which is the first symbol of our input string. Now at Q1 state our logic will start, because first our logic will start with the first character of the string. Okay. So now what logic, well, now we can say that in our logic, what is the step number 1? Step number 1 said that if my pointer is pointing to the small a, so what we are going to do? Small a is replaced by a capital A. So here you can see that by doing this we are going to change the state. So here small a is replaced by a capital A. Now after doing this, which direction we have to move? We have to move the right direction. So you can see over here, small a is, I am going to read the small a, and this a is replaced by a capital A and move my head to the right direction. So I have replaced this small a by capital A, and now my head is moving to the right side over here. So for doing this I am changing the state Q1 to Q2. Now doing this I am changing my state from Q1 to Q2. So here we have count of first A. Okay, so right now we are at set Q and move my head. Now at Q. Now my step number 2 said that if there is no B, we have skip. We have to reject the string, sorry. But here there is a B in the string. So we do not need to reject it, but we need to move to the right side and check whether there is a B or not. So for finding out the B, what we are going to do? We are what? Replacing the character small a by a. It means that in a between path, if I read the character small a, we do not need to change it. So what we are going to do, small a is replaced by a small a. Okay, it means that we are not changing this symbol, just move my head to the right side to find out the first v. So here small a is replaced by a small a, so my head is replacing the symbol with the same symbol and move to the right. Now for skip this thing, what we are going to do, we are using the self loop. So after doing this, which state we stay over here? At q2 state, we at a q2 state. Now at q2 state said that if you are skipping a small a symbols, and after this if you are found b small b, so what we are going to do? So q2 state said that if you are found a small b, replace by capital B and move to the left side, because you have complete your first round, first A, first B. Now start to the second count. So our head is replacing the small b by capital B, move to the next state and move my head to the left side. Okay, now we are finding out the leftmost A. Now we need to start the counting, second counting. So for start the second counting, we need to remember where our first counting is started. So when you are moving to the left side, so the term at Q3 state, you can see over here, if you are getting a capital B, it is replaced by a capital B as it is moved to the left side. If you are moving to the left side, if you are read small a, replace the with the same symbol. Do not change anything. Replace it with the same symbol. Just move to the left side. Just move to the head to the left side. So here, if it is A is replaced by A. Move to the left side. Now we can see that the last counting thing, which is replaced by a capital A. How capital A we have reached? So it means that by moving to the left side, okay, now you have reached the capital A, which you have a where you can start where you have a last count. You have started your last count. Okay, so it means that in the next symbol you need to start your next counting. So at Q3 state said that if capital A appears, so capital A keep as it is, capital A replaced by a capital A and move to the right side. It means that at this symbol you have to start your second counting. Okay, so at Q1 state, right now you are Q1 state, so the same procedure you have to repeat for the second counting. Second A replaced by a capital A, again, so same procedure is repeated. Small a is replaced by capital A, move to the right direction. So we are at Q2 state. Now at Q2 state, you are going at Q2 state, your tap head is point to capital B. So at Q2 state we have to just skip this symbol because it is already counted, so we need to skip this. So capital B is replaced by the capital B, move to the left side because we are going to find out the second B. So if my head is, move to the left side. Now second B appears, second B is replaced by capital B. So here you can see that, okay. Now move to the left side. So here my head is moved. Now moving to the left side, if capital B appears, replace this symbol as it is, move my tap head to the left side. Left side. Now, if capital A, it means that we have to start the counting, next counting to the next symbol of this A. So, A is replaced by A, move to the right side. So, here you can see that move to the right side. Now, when at Q1 state you get capital B as a input, it means that at a Q1 state now we are going to read a capital B. It means that all A, small a are converted into a capital A. So all small a are counted. It means that small b also counted. Okay, so at Q1 state we need to check whether all small b is converted into a capital B or not. If not, reject that string, but if yes, we need to accept that string. So how we are going to check this? So at Q1 state, if I get capital B, so capital B is replaced by capital B, move to the right direction. Now at Q4 state, so this self loop indicating the number of capital B is up here at the right direction. The capital B we need to skip. It means that capital B is replaced by capital B, move to the right end. So here this Q4 state is helping to move right end of the string. So to move this Q4 state is helping to our our tap head to move the right end. Okay, so again capital B is replaced by B and move to the right side. Now we are skipping. Now we are at delta. It means that all small b is converted into capital B, then and then we can reach this delta. It means that we have reached at the right end of the strings. So at Q4 state, if you get a delta replaced by a delta, we stop over here and move this transition and transfer this transition into HA. HA indicating the accepting state. HA. So always remember in a Turing machine HA, so the string, after tracing the string, if we reach at the halt in accepting state, this is called accepting state, we can say that the string is accepted. So I hope this concept is clear to you. Now again, let us take the another example which is invalid. So suppose double A, triple A, 4B. Okay. So these are the invalid string I have taken. Now let us trace the for this invalid string. Now check whether this string is accepted or not. So by using this logic we check whether this string is accepted or not. Now my head is delta. Right now we are at Q0 state. So Q0 state said that delta is replaced by a delta. Move your head to the right side. Now my head is right now over here. So counting this, small a is replaced by capital A, finding out the small b. So small b is replaced by capital B. Now move to the right side. So here you can see that okay, now second, this is second A, second B. Now third A, moving to the third B. Okay, now we move to the left side, to the leftmost symbol A. So here we can see that this is my triple A. If you see that like this, I have write down over here. After converting this small b by capital B, we move our head to the left side. Okay, so left side, the last converted small a to a capital A symbol. So here we have reached, and according to this we have to replace the capital A to capital A and move to the right direction. So my head is pointing to this. So my head is pointing to this capital B. Now according at Q1 state, right now we are at Q1 state. Now Q1 state says capital B is replaced by capital B. Move your head to the right side. So my head is moving to the right direction. Okay, so here, so B. Now we are at Q4 state. Now Q4 state said that if you are getting the capital B, replace by capital B by capital B and move to the right direction. So my head is going to the right direction. Again this is my self loop, again is repeated. If I get capital B, again this capital B is replaced by a capital B, move to the right side. Now if you see, we are at which state? Q4 state. Now our input symbol is B. We are at Q4 state. Is there any transition for a small b? No, there is no any transition for a small b. It means that missing transition for a small b on a state Q4. It means that if the transition is missing, it means that this is the invalid string and we have to reject over here. So in this way we can design this state transition diagram which accept the language a raised to n, b raised to n where n is greater than equal to 1. One thing you have noticed, one thing you need to consider over here, if my n is greater than equal to 0, so what happened? What change should occur in this transition diagram? So only one change is we have to make in this transition diagram is, if n is 0, it means that my valid string is minimum length a raised to 0, b raised to 0. So we need to accept the null. So here if you remember, in a tab there is no null symbol we can use, we have to use delta in place of delta. It means that denoted null symbol, so empty symbol, so empty string, so we need to accept the empty string. So whenever at a Q1 state we get the delta is replaced by a delta, we stop at this and we need to accept it like this. So only one change, if n is greater than equal to 0, we just add this transition at my Q1 state. Delta is replaced by a delta because we need to accept the empty string. So delta is replaced by delta and stop over here. So I hope this concept is clear to you. Thank you. Thank you all.